Dear students, good evening. My name is Rajan. I'm a assistant professor in Department of Information Technology in Hindustan Institute of Technology. Today we are going to see in our lecture topic the data structure to introduction. First, you want to know the what is mean by data structure. Data structure is the way of organizing and storing the data into the computer. We are having so many data, for example, raw data, for example, Word file, PDF file, or next PPT, next or video file, audio file. So many files we are having, Excel files, so many data we are having. How we are going to store in our computer? That is called which way we are using to store the data in computer. So it is called data structure. Once again I am repeated, data structure means the way of organizing and storing the data into the computer. In our computer, how we are going to store our data, then only we can easily access our data. You want to understand? Okay, for example, we can say uh, the data structure examples are arrays, linked list, stack, queues. These are the examples of data structure. Okay. Next, the classifications of data structures. Data structure classified into many ways. For example, first data structure classified into two types: primitive data structure, non-primitive data structure. In primitive data structure, we can store only one bit of information only we can store. For examples, integer, float, character, double. These are the data types are primitive. We can call primitive data structures. Next, non-primitive data structure. What are the non-primitive data structure? Non-primitive data structure again classified into two types. For example, linear data structure and non-linear data structure. What is meant by linear? The data will be stored in contiguous memory allocation. The data are going to store in linear order. Okay, that's why we are calling the linear data structure. Linear data structure again classified into two types: static data structure and dynamic data structure. Static data structure means we cannot store the already fixed size of memory allocation. Okay, fixed size of memory allocation. We want to store any extra data we cannot store because they already fixed. The memory size is already fixed. We can store only that much of values. Okay, for example, we can say arrays. What is meant by array? Array is called as the we can store the multiple values in a single variable. Okay, similar types of variable we can store in the array. Array is generally it is called as a fixed size of memory allocation. Next, we are going to see dynamic memory allocation. What is meant by dynamic memory allocation? The memory we can actually, for example, we can say the linked list and stack. We can say the examples of for dynamic memory allocation. We are having, so in stack we are having 10 elements. We want to store extra 2 elements. Easily we can resize the stack and add more 2 elements. Next, linked list. Linked list means it is also same. It is also called as the dynamic memory allocation. We can store the multiple values. We want to delete the values and add the values. Both operations we can perform in linked list. Next, going to see nonlinear data structure. What is meant by nonlinear data structure? Nonlinear data structure means the data will be stored in hierarchical manner. For example, we can say the in hierarchical manner, or for example, network manner. We can say the in nonlinear data structure having two types: the trees and graphs. Trees and graphs. Okay, so many types of trees. The trees are stored in the hierarchical manner structure. Graphs are connected with the network manner. These are the classifications of data structure. I think you can understand now the classifications of data structure, and also you understand the data structure also you can understand. Now next topic, you want to see the what is meant by primitive data structure. Once again we repeat these all the topics. Primitive data structure. Primitive data structure are the basic data types that are already built into a programming language. They can store only one value at a time. Already I said we can in primitive data structure so many examples we can say: integer, float, character, boolean. These are all primitive data structure. We can store only one bit of information only we can store. Okay, it is a specific memory location. This is the primitive data structure. These are the sizes of primitive data structure. For example, how many bytes we can store in integer and float and character. Okay. In the integer also classified into many types: byte, long, short, and int. And float also classified into two types: float, double. This and in float 4 bytes we can store, and double 8 bytes we can store. Character 2 bytes we can store. So okay, this is the primitive data structure. Next we are going to see the non-primitive data structure. Non-primitive data structure are created by the programmer using primitive data types. They are used to store and manage large amounts of data efficiently manner. There are mainly the non-primitive data structure classified into two types. For example, linear data structure, non-linear data structure. Linear data structure means we can say the examples of arrays and linked list, and non-linear data structure we can say the examples of trees and graphs. These are the examples, okay, arrays examples and trees examples. Next we're going to see the linear data structure. Linear data structure which can data elements are arranged one after another in a sequence. Each element is connected to the on or before one before after it. Okay, for example, linear one by one we can store in a sequential order we can store. So that is called linear data structure. This is the example. And also non-linear data structure, we can say the examples of trees and graphs. A non-linear data structure is the elements are not stored in the sequential manner. Instead of they are connected in a hierarchical or network like. For example, this is the tree structure we can store, and also graph. This is the graph structure we can store. The graphs are actually so many vertices connected with the edges. Okay, this is the like this is the so many graphs are okay, connected graph, iterative graph, uniterative graph. So many graphs are available. Okay, we can say we're going to see the later.